Blocks teach math! Crewton Ramone's House of Math. For more on this. Alright, starting kind of in the middle, but we're going to start with 1/2 base times the height is equal to area. Well, where does that come from? It's not just something you memorize, it's something you should be able to get their hands on. Let's start off with length times width. This is where we should start. This times that tells me, length times width tells me the area of that rectangle. Not hard. So the area of this rectangle is 8. And we can do all kinds of math with just these blocks right here, where instead of just memorizing 2 times 4 is 8, or 4 times 2 is 8, and if you look at this, you should be able to see that there are indeed 4 2's in there. If I play with a rectangle, I can see, oh, the across is 4, the whole thing is 8, 2 is the down. And if I turn them the other way, the across is 2, the whole thing is still 8, right? Oh. And of course this times that is that. Length times width, length times width. And what about triangles? Well, triangles aren't as easy to count. So, let's talk about it. What's this called? They should say base, because it is. What's that part called right there? Oh, height. What did I just do to the base? I just cut it in half. Put this piece right there. Oh, look what shape that is. Well, that's a square, which is a type of rectangle. But there it is. 1/2 the base times the height gives me the area. Let's do it again. What's this thing called? Well, it's a triangle. Here's the base. Oh. There's the height. And little kids, it'll take them a while to figure out how to... Oh, there it is. Now you can see 1/2 the base times the height gives me the area of this thing. Okay, very simple. How about Pythagorean theorem? Okay, we've all seen this, or I hope you've seen this, where I take these guys and I make a lovely triangle. So, you have to have these expensive plastic blocks. Well, no you don't. We're going to play with these other guys in just a second and show. But can you see now, that's 5. That's okay, 3, 4, 5. They should know that. I'm going to square these guys. And then I'm going to square that guy. And then I'm going to square this guy. Oops, not a square. Need one more. And now I can see, and by the way, it was a little kid, and I don't remember where, that showed me this. Hey, mister, look. Instead of, because I used to trade in the blocks and so forth to make them all fit, why not just do this? Oh, it's the same. You're going to see that 16 and 9 is the same as 25. A squared plus b squared really does equal c squared. There it is. And then they can get the other ones where they see that c squared minus one of the other ones gives you the other one. Right? Okay, fine. Oh wait, what about playing with these guys? And these guys. Just make them playing around with blocks. Alright, oh, and you could do that. But anyway. Okay, so here I'm going to make these guys look like this. I'm going to put this guy right there. Okay. Now I don't have numbers even. And this is great for the little kids. We're just 100% algebra. Generic math. You know, I'll put one like this too, just for fun. Okay, so I could be playing all with... But see, that's what you do. You play with these blocks. But people have forgotten how to play with these blocks to teach kids math. Little kids can get this concept. I've been in classrooms full of second graders where the second graders went home, got attacked at a party. It was great. The parents are like, who the heck is this guy? Because their kids came home talking about Pythagoras and they're excited. And when they explained it to their parents realized that they actually understood what I was talking about. Because they had their hands on it. And don't just watch this video. Play along. This is a piece of cardboard. Cut it out. Well, how did I do it? I just took some blocks, right? Cut them to size, using an X-Acto knife and some scissors, and then cut these guys in half, and then cut them in half. Not hard. Okay, so, right, started off with a piece of cardboard like that, cut that in half, and then cut those into, right? Oh, and look, we could do fractions, but that's not the point of this lesson. Can we see quite easily that if this one is 1, that it takes 2 pieces, and that this would be 1 of 2, and then I could cut those in, and this would be a quarter of the whole thing? But, like I said, that's not the point of this lesson. The point of this lesson is a squared plus b squared equals c squared. If I look at these guys, and I'm just gonna be generic and talk about it. Let's call this 1, 1, and then we can talk about this being square root of 2. That this is the square root of 2. We could also say that this is 2, and this is square root of 2, and this is square root of 2. Use my imagination and change the numbers around. But we got this and this, and these 2 blocks should be the same thing as this block squared, is what Pythagoras said. So that would be these 2 blocks. I can take, well, actually, let's do it real fast. And you can see that this is 2, right? This would be a 2 block. That would be basically playing with these. But man, little kids, it's too small to try and do it. So we're gonna play with slightly bigger blocks, right? That they can get their hands on. I'm talking about preschoolers, kindergartners, first graders, second graders, playing with blocks. They love to play with blocks, build towers. And you could just talk to them while they're playing and say, hey, look at this. So I take this. This is kind of cool. And I take this. So when I square this, this is going to be really hard to square though. Oh, actually it's not. Because here's what I'm going to do. I'm going to take this, and can you see that I'm going to put this piece here, I'm going to put this piece here, this piece here, and this piece here. And lo and behold, these 2 are exactly the same, right? A squared plus b squared equals c squared. Here it is, squared. There is a 2 square if this was 1 and 1. Is that hard? And that when I take, there's nothing hard about this, but your kids can see it. It's not difficult for them to comprehend or grasp. No concept is beyond the understanding of a child if it's presented at the child's level. And again, don't just watch this video. Get the hands on the blocks. More sensory input. This is not as powerful, or excuse me, what I'm about to do is not as powerful as this. First, in the concrete, with their hands on the blocks. Draw a picture of it. I can draw a picture of what I just did. And I can label my picture. I'm going to call this 1 and 1. Then this has to be square root of 2. Because the whole thing's a square, and what's one side? And see, this can be advanced, but it doesn't have to be advanced at all when you bring it down to the child's level. Didn't we just make a square and one side? The whole thing is 2. Isn't one side square root of 2? Well, if they don't know what square root of 2 means, if they don't know what square root means, and they don't know what this symbol right here means, that symbol is square root. Square root means one side. 9. Square root of 9 is 3. They can see it. They can get their hands on it. No little kid is mystified by this at all. Just because you were mystified by square roots and you couldn't remember that the square root of 16 was 4, not 8, doesn't mean that your kids have to be. So there's another square. Isn't that one side? Okay, so if this whole thing is 2, one side must be the square root of 2. And we know, to go a little further, that if this whole thing is 16 and I take the square root of it, isn't that the same thing as 4? Well, of course it is. But I can also say it's the square root of 16. Right? Okay, when the whole thing is 2, and if I have a square and the whole thing is 2, well, I'm just going to say one side square root of 2 because it's a radical and it's a repeating, and we can talk about that more. But we don't have to you overthink it with the little kids. I know you do. Just keep it simple. I'm probably going too far here for you. Okay, so now I can see here when I draw my picture that really, and again, the picture is not as potent. And look, especially when I don't draw it drawing not to scale. These are supposed to be squares. But they can see that, oh yeah, and graph paper is great for this, by the way. That, yeah, the area of this square, this should be a square. If I was really into it, I'd measure. That this whole thing is 2, so this one side is square root of 2, and certainly if I square 1, I just get 1, and I square 1 again, I get 1, so a squared plus b squared, add them together, I get 2. Look, I'm playing with blocks. I'm just playing with blocks. We're having fun. Okay, that's the whole lesson. We're done. Right? Do it again tomorrow. Do it again a few days from now. And they can see that, right, as they're playing. And then, you know what? Leave it alone. Because you're trying to make that, it's hard to do. Let them play. Now, look, build something. Right? Make a little, well, this is top view, so it's not going to work. But oh, here, I could do it like that. I can pretend this is the floor. And, you know, we could make a little house or something. And just play with, you know, kids like to play with blocks. Play with the blocks. Let them play. As they're playing, you can bring this up. Right? And then, here are the symbols. There is the drawing. This is definitely not as clear as this or this. But once you do this, and then move to this, and then go there, of course that makes sense. That's what we did. We took 1 and squared it. We took 1 and squared it, which is the same thing when we add them together. 1 plus 1 is 2. This is a 2 square, right? So this is square root of 2 squared, the 2 sides. Here is the square root of 2 again. Square root of 2 times square root of 2, the whole thing's 2. Right? Square root of 3 times square root of 3, the whole thing, excuse me, square root of 9, square root of 9 times square root of 9 is 9. Because that one side is non-different from square root of 9. We happen to know that square root of 9 is the same thing as 3, but I can say square root of 9 times square root of 9, 9. And I know that square root of 9 is 3. I can see that one side is 3. I can see that one side is 3. And of course 3 times 3 is 9. So this whole thing, 9, oh look, I just changed the symbols. This stuff shouldn't be mystifying, shouldn't be hard, should be easy and fun. Play with blocks. Again, don't just watch videos, follow along. If you don't have these, you certainly should probably have these in your preschool or in your kindergarten or something like that, and perhaps at home. My mom got these for me in 1969. Sears Roebuck catalog, delivered to Maui at great expense on a boat. Anyway, so I could play and fool around with these blocks. And you know what? My mom, a school teacher, had never seen any of this stuff until I met a man named Jerry Mortensen. Length times width is where we started, right? Half the base times that plane and getting these guys, right? So I went from finding the area of these guys to fooling around with a little Pythagoras in the space of a few minutes. Just play and have a good time. All right, Crewton Ramone's House of Math.com. 4 more.